Alright, so today we're going to be talking about 3-sum closest given an integer array nums of length n and an integer target. Find 3 integers in nums such that the sum is closest to target. Return the sum of the 3 integers. So you don't want to return the indices of the, or like the numbers, you want to return the, just the sum. You may assume that each input would have exactly one solution. So going through this, closest thing to get to 1 would be this, and this, which would return 2, and it's just 1 off. This would return -1, which is 2 off, so that's obviously further. Here, it doesn't matter what you add up, the sum's still going to be 0, right? And we're going to do is edge cases as always. Oh, and so for this question, we're going to be doing a 2-pointer method because, well, since we need to find 3 integers, we can just use a 2-pointer method, as well as one of them would just be in a for loop. And so we will be able to solve this with that. So as always, we do the edge cases, right? So we're going to, okay, well, we should start with typing if correctly. If length of nums is equal to 0, or nums is none, or target is none. Basically, we can't even solve the solution if we can't solve the problem if those are the conditions we start with. So we're going to return 0 for that. Now we're going to initialize variables. This isn't okay, yeah. So we're gonna have closest sum is equal to float infinity. So pretty simple. This is just the sum that we find closest to target. And here we're going to do nums equals sorted nums. And so this sorts the array. This just sorts the array. It will help us solve the problem later on. So it's good to have a sorted array. So now we're going to have for I in range of length of nums -2. We can do -2 here because if the range of the length of nums takes us to the very last index of the array, but since we need 3 numbers, like return the sum of three integers, we don't have to go to the very last one, right? There's no point in going to the second and last one too, because that only leaves us 2 numbers. We can go to the third to the second to the last. Wait. Last one, second to last, third to last. It would be third to last. Or is that even right? We will just go to the third index before the last one, and then we can stop there because that allows us to have 3 numbers. So that's why we can do -2 here. And now I will explain this condition at the very end because it's kind of confusing. But nums I -1. But basically, this just means if we have the current index where it equals the last index, if we weren't able to find an answer there, we won't be able to find an answer here because except for the first possibility we saw in the previous loop, everything else is going to be exactly the same that as we saw in the previous loop. So we don't need to go through this loop again because it would just be kind of redundant. But maybe it's easier to see with an example. I'll try to make one later. So we have left, right is equal to I +1 and length of nums -1. So this gives us 3 pointers, right? So in the very first loop, I would be here, I +1 would be here, and then length of nums -1. So this is how we're going to do 3 pointers, and then slowly move in. And since we already sorted it, it would be in a different order, right? So I can run it through like after all the code is done. So here we'll just do while left is less than right, because this is like our 2 pointers, and this is how we like close in the window. And then we know once they're equal to each other, then we know like the window's completely closed. We're just going to go through stuff that we already went through, so there's no point in going over again, right? And so now we have temp sum, which is nums I plus plus nums left plus nums right. Temporary sum, kind of self-explanatory, right? If temp sum is equal to target, then we can just return temp sum. Because if we're able to find the target, that's obviously the closest thing you can get to the target, so you can just return that and move on with life. If not, then we have to go on to the bottom here, which is not target minus temp sum. And we have to take the absolute value because it's possible we go under, or if we're over, then it's still positive. So we need both sides to be as fair as possible. So we're going to take the absolute value of both sides and make a comparison. If target minus temp sum, the absolute value of that is closer than target minus closest sum, then we know whatever we have right now as temp sum is closer to the target than whatever we have in closest sum, right? So we have to replace the value, and then depending on the value, so if temp sum is less than target, then we know we need to move the left pointer over. So we're going to do left plus equals 1, and then else, since we already covered the case where temp sum is equal to target. Now if temp sum is less than target, so the only case here left over would be temp sum greater than target, right? And so if it's greater than, we want to move the right pointer over 1 because we need to close our bounds. And then here we return closest sum, whatever value that may be. And so we'll just run through this example real fast. So this is our numbers. So I'll write at the very bottom. So we start with -1, 2, 1, -4, right? And so we go here. The length is not 0. We do have a value. It's 1. I'm not going to write down the 1 though. And then we initialize variable closest sum is equal to, so I'll do closest sum is equal to float infinite, right? And now we call sort, right? So now we're going to sort this, so it becomes -4, -1, and then this will be 1, and this becomes 2. So now we have the sorted version, right? And so now we're going to go through this and then figure it out. So as we go through it right now, I would be equal to 0, left would be equal to 1, right would be equal to 0, 1, 2, 3. And so this only really happens when it's this case, so I'll come up with a test case afterward, but just going through this one first. So we would have -4, -1, and 2. We add those together, that gives us -3. -3 is not target, so we're not going to return yet. -3, 1 minus -3 is 4, and then minus infinity, so this is going to be infinity, so it's obviously less than. So now closest sum gets updated to -3, right? And now we're at -3. We're like, -3 is less than 1, so we got to move the left pointer over by 1. Now it's 2, and now we go through it again. Our temp sum is now equal to -4 plus 1 plus 2, which gives us -1. And it's not target, so we do that. And then now -1 is closer to 1, so we update closest sum to -1. And then -1 is still less than, so we update this. However, we're now equal to, so we don't loop through this. And now we move I over by 1. And then we reinitialize 1, 2, 3, -1, 1, 2. Add that together, becomes 2. 2 is closer to 1. So now we report it with 2. And then we increment this again, but then we're done here. So we gotta go here. But then since the length of this is 4 minus 2 is 2, we don't have any more place to go. So this is relevant, these are relevant, and that's how we return 2, which is our solution, right? And so I'll just give another example where there's a repeat, where there's a repeat, and then we can see why this condition will help us, right? So we're going to do this. I'm just going to do infinity for here. I'm too lazy to type the whole thing out. And then I equals 0, left equals 1, right equals 0, 1, 2, 3, 4, 4. Right? And so now we're here. We do this, negative 3, right? So negative 3 is the closest so far. And same run through. And then basically we're going to eventually hit this. We're going to hit this and these two, right? Which would give us negative 1, which is the closest that we can get. And so I'm going to go I equals 1, right? And this is now 2 and 4. And then so here we get 0, which is even closer, right? And then we go here, which makes it negative 1 plus 1 plus 2, which gives us 2, which is also just as close, but we don't need to change it because it's not less than. And in that case, like, you know, that's where it has multiple solution. This will guarantee you only have one solution, but that's not what I'm trying to show, right? So in here, we know that the combinations we can see here are negative 1, and 2. We can see negative 1, 1, and 2. We could, and then, yeah, that's all we'll see because we're trying to get a target of 1, right? And so those are our possible combinations when I is equal to 1. Now when I equals to 2, and this equals to 3, 2, 3, 4, that's literally negative 1, 1, and 2, which we have already seen, right? So if we didn't find the solution already, there's no way we can get any closer to it by any of these conditions. So we can just automatically skip this loop and just go to the next iteration. But in the case of this problem, there is no next iteration because 3 is 5 minus 2, and that's not part of the length. So we don't need to do any of that. And so I hope I don't have anything that's not supposed to be in there. And if we run it, it works. There we go.